This theorem is the uniqueness theorem. It's a slightly stronger version of the previous one. So you still have an initial value problem, y prime equals some function f of x comma y. You have an initial condition, y of x naught equals y naught. You have this open rectangle that's going to contain your initial condition. And now you have a f of x comma y is continuous, but also this other thing, it's partial f, partial y. This kind of backwards six-looking symbol is the partial symbol for the partial derivative. You normally learn about this in vector calculus, but I'll go over what it means in the next videos. It's really just like a way to take the derivative of this function f, and you treat y as a variable, and you treat x as a constant. And it's like you just take the derivative with respect to y with treating x as a constant. All right, but so you have, this function f of x comma y and partial f, partial y. They're both continuous on the open rectangle R, which contains your initial condition. Then, that implies the initial value problem, and this is the different part, it has exactly one solution within R that's going through the initial condition. So right before, with the existence theorem, you're at least guaranteed you have at least one solution. So you still could have infinitely many, could have one or more than one. But this one is actually saying, well, okay, you have exactly one solution. So you're not going to have two or three or an infinite number, you're going to have just one. And again, so right, if these conditions aren't satisfied, then you know absolutely nothing about the solution. So even if, f of x comma y and partial of partial y are not continuous, there's a chance you still have a unique solution. You still have exactly one solution. There's also a chance you don't have a unique solution. So right, just keep that in mind. This, implies you only note the statement B, the statement on the right, if the statement on the left is true. And now we're going to get into some examples, and you're going to see how this shows up and how it applies. And when this statement is true, we'll know something about the solution, but when the statement is false, we're going to get a variety of different behaviors.